So in this video we're going to look at the volume of a pyramid. Here is a diagram of a pyramid. The top part is the apex, and in this case we have a regular base that looks as though it might be a square base, but we would need something like this to make that clear. So we have a square based pyramid here. Now the formula for the volume of a pyramid is 1/3 of the area of the base times the height. So V equals 1/3 AH. It's a nice simple formula to use. So here we have a square based pyramid. The length of the side of the base is 12 and the height is 25. So the volume then is 1/3 A times H. Now we can work out A separately. It's length times breadth, 12 times 12 because it's a square that we're dealing with, and 12 times 12 is 144 centimetres squared. So 1/3 of 144 times 25, that might be one for your calculator, and that gives us exactly 1200 centimetres cubed. Now, this is another pyramid, but if we look at the base, we have 1, 2, 3, 4, 5. So that would be a pyramid with a pentagonal base. In a question like this, we're almost always given the area of the base. You wouldn't be expected to work out the area of the pentagonal base. So the area is given, which makes the calculation much easier. We're also given the height, but there's something to notice here. We've got the area in centimetres squared and the height in metres. So what I'm going to do is to change this to 120 centimetres. And volume equals 1/3 of the area times the height, area of the base times the height, so it's 1/3 of 30 times 120. We could probably do this without a calculator, so 1/3 of 30 is 10. 10 times 120 is 1200 centimetres squared, centimetres cubed. Now one thing I'm going to do is to work out the capacity, the liquid volume. So I'm going to divide this by 1000. Now 1000 to 100 divided by 1000 gives me 1.2 litres. This third and last example shows a pyramid with a triangular base. So we've had a square base, we've had a pentagonal base, and now we have a triangular based pyramid. This is not any old triangle, this is an equilateral triangle. So we have 1, 2, 3 sides all the same. Now we're given the height of the pyramid, we're also given the length of the edge of the base, but we're not given the area of the base, so we're going to have to calculate that. What I've done here is I've got an equilateral triangle which represents the base, and we're going to have to work out the area of this triangle. Now, so we know that this is 18, and this is 18, and this is 18. The area of a triangle, well, there are different things that we can do. Because it's an equilateral triangle, all 3 sides are the same, and all 3 angles are the same as well. So this angle in here is 60 degrees. Really the only type of triangle that you've worked with so far has been the right angle triangle. So what I'm going to do with this shape is to split it into 2 right angle triangles. And we're going to use our knowledge of, we could in fact use Sohcahtoa, we could also use Pythagoras to work out the height of the triangle. Now the first thing is to deal with this 18. Because I've split the triangle down the middle, I'm also going to split the 18 into 2 equal parts. So we'll get rid of that and we'll write a 9 here. I'm going to remove some of the information from the triangle because we don't need all of it. I can get rid of this. And let's use Sohcahtoa then. Sohcahtoa. Now you can see we've got these two sides here. I'm going to use, in fact I'm going to rub out the 9. So let's identify the sides then. Well, this is the hypotenuse because it's the longest side, the one opposite 90-degree angle. So I'll put a tick here and a tick here. And this is the opposite side because it's opposite the 60 degrees. So I'm going to put a tick here and a tick here. And you can see then that it's the sine ratio. So sine of x is O over h. Sine of 60 degrees equals, well, small h for the opposite and 18. Now I'm going to multiply both sides by 18 to get rid of the dividing 18. So h equals 18 times the sine of 60 degrees. That's one for your calculator. And that gives us 15.588 millimeters squared. Now, the area of the base that's to say the area of the base of the pyramid, which is a triangle, is a half of the base times the height. So that's 1/2 of this. Now we know that's 18. Times this height here. We're still working with the triangle, we're not working with the pyramid at the moment. So that's the height that we just calculated, that's 15.588. That gives us 140.3 millimeters squared. And this, of course, should not be here. That's the length. So all of that working was in order to calculate the area of the base of our pyramid. Now, final thing to do, the volume of the pyramid, 1/3 of the area of the base times the height. So it's 1/3 of 140.3 times the height of the pyramid, so it's 15. And that gives us 701.5 millimeters cubed.